On number 13, negative exponents. P squared times 3p to the negative 1. I'm going to start by identifying those like bases. I have a coefficient 3. It would go with a coefficient 1. That is implied. And then I have p squared and p to the negative 1. I would start with multiplication and just use that product power or product rule. 1 times 3 is 3. And then p squared times p to the negative 1 is p to the 2 plus negative 1. When I combine in the exponents, I'll have 3 times p to the 1. That eliminated my negative exponent without me having to do any additional work. 3 times p to the 1 is just 3p, and that is your answer. Number 14, 3r to the negative 2 times 3r. I've got 3's here and here. And then I have r's. I have a r to the negative 2 and a r to the implied 1. 3 times 3 is 9. R to the negative 2 times r to the 1 is r to the negative 1. I cannot stop here because this negative exponent. Now, to take care of negative exponents, you start by making it a fraction. Just go ahead and make the 9 a fraction as well so you don't have to worry about mixing anything up. Now, to make negative 1 a positive exponent, I'm going to flip the reciprocal of only this base. That's going to give me 9 over 1 times 1 over r to the now positive 1. Now I'm ready to multiply straight across. 9 times 1 is 9, and 1 times r to the 1 is r. And that is your answer. 3k to the negative 2, there's a couple ways you could start here. You could start by distributing the negative 2, or you can use the negative 2 and change the entire base. Remember, everything in the parentheses is the base. My advice is deal with that negative first. If you make the base a fraction, you can flip the reciprocal of the entire thing and it will make the negative 2 become positive 2. So when I flip this, I'll have 1 over 3k to the positive 2. Okay, it's still on the outside of the group, but now it's positive instead of negative. Now this is a product power rule with a quotient. We are going to distribute that 2 exponent. First, it's going to go to the 1, 1 squared. Then it's going to go to the 3, 3 squared. Then it's going to go to the k, k squared. There's no point in leaving 1 squared in your problem. 1 times 1 is 1. 3 times 3 is 9. And that is your answer. On this one, I have a power rule down here in the denominator. I would start here. Instead of trying to combine stuff from all over the place, start by getting rid of the parentheses. I think order of operations tells you to start with parentheses anyway. So when I work through this, I'm going to leave the b, I'm going to leave the 3b, and I'm going to work on this b to the negative 2 squared. The product rule says, the power rule says keep the b, multiply the exponents. So negative 2 times 2 makes negative 4. Now I can look for my like bases. I've got this 3 that's going to go with the implied 1 in the numerator. And then look at my b's. We have not seen that yet. We now have 3 copies of the b. You've got options. You could start by combining these 2, or you could start by combining these 2. Doesn't matter which one you do. What I typically do is if I have 2 on one side of the fraction, I combine those first. So the first thing would be 1 over 3, and then I'll keep the b up top, and then I've got b to the 1 times b to the negative 4, which becomes b to the 1 plus negative 4. Next step would be to simplify that addition, and I'll have 1 over 3 times b over b to the negative 3. Now I can focus on combining that set of b's. I've got a b to the 1 over b to the negative 3. This is a quotient rule. 1/3 is still untouched. B to the 1 minus negative 3b's from the bottom over 1. Now, minus negative 3 will become a what? Positive. And we'll have 1/3 times b to the 4th over 1. 1 times b to the 4th is b to the 4th. And 3 times 1 is 3. And that is your answer. Again, I have this negative exponent on the outside, so I'm going to take the entire fraction and I'm going to flip it over to make that exponent positive. So my denominator, 3v squared times 3v to the negative 3, moves to the numerator, and my numerator, v to the 3rd, moves to the denominator. Now, the negative 1 exponent didn't go away because I flipped it. It became positive. Now, if you remember exponents of 1, you don't need them. They're just implied. So technically, we opened that group up by flipping the reciprocal. Now, if we're looking at this for like bases, I've got a 3, and an implied 1. And I have a v squared, a v to the negative 3, and a v to the 3rd. So when we combine our coefficients, we've got 3 times 3 is 9 over 1. And then I have 2 copies of v in the numerator, so I'm going to start there. V squared times v to the negative 3 will be v squared plus negative 3. That combines those exponents using addition. Now the v to the 3 in the denominator stays. We have not touched that one yet. When I do my addition, I have the 9 over 1 still, and then I have v to the negative 1 over v to the 3rd. Now I'm going to use the quotient rule to combine the v's.
Please call the office. Tommy in maintenance, please call the office.
I'm going to keep the 9 over 1, and then I've got v to the negative 1 minus the 3 v's that were in the denominator, leaving me just a 1 in my denominator. 9 over 1 times v to the negative 4 over 1. I have to deal with that negative exponent by flipping the reciprocal, which gives me 9 over 1 times 1 over v to the now positive 4. My answer is going to be 9 over v to the 4th. And that is all on that one. The last question, number 18. There's a lot of different places that you could start on this one. I'm going to start with all of these parentheses. I'm just going to distribute all of those outside exponents. I'm going to start with the first group of parentheses. I'll have 2 to the 3rd times a to the negative 2 to the 3rd times 2 to the 3rd times, what about this a times a to the 3rd? Can I combine that? A to the 1 plus 3 makes a to the 4th. Lost my a. And then it also gets that exponent of 3. I don't like that. It looks like a 6. A to the 3rd to the negative 1 is going to multiply. And 3 times negative 1 makes negative 3. Now I'm going to go through and I'm going to see what else I can simplify using that power rule. And I can do my coefficients. 2 to the third is 2 times 2 times 2, which makes 8. A to the negative 2 to the third becomes a to the negative 2 times 3, which is a to the negative 6. 2 to the third is 8. A to the fourth to the third becomes a to the 4 times 3, which is a to the 12. A to the negative 3 is still patiently waiting in the denominator for us to deal with it. Now, the mess is gone. We can actually focus on the numbers. I've got an 8, an 8, and an implied 1. And then I've got an a to the negative 6, a to the 12, a to the negative 3. I'm going to start in the numerator. 8 times 8 is 64. A to the negative 6 times a to the 12 will be a to the negative 6 plus 12 over a to the negative 3. 64a to the positive 6 over a to the negative 3. I need to combine these a's using the quotient rule. I'm still going to have my 64, or 64 over 1, times, it'll be a to the 6th minus negative 3. Remember, the quotient rule says you have to subtract, over 1. It's going to be 64 over 1 times a to the 2 negatives make a positive, 9 over 1. My answer is going to be 64a to the 9th. And we are done. Now, we're not going to go over 19 and 20 because that's the mixed review challenge. Those last three were challenge enough. So, we are done.